You bake a big S-shaped cake. All right. So again, we call this C thing constant of integration. And if we have time at the end of the period, I'll tell you a story about the constant of integration. Got it? Yes. All right. So it's time for a little symbology. You don't have to write the word symbology because I don't even know if that's a word or if it makes sense or what it's related to. I like the word. So we're going to use this thing called the integral symbol, and it represents the antiderivative of something. You may have seen this before in some texts or on some crazy-looking math program. If you ever watched the show Numbers about a crime-fighting mathematician, you might have seen it. It looks like this, so write that. Woo! What is that thing? It's supposed to be an S that's like seriously elongated. I'm terrible at writing them. It's like my weakest thing in the world. It's like that. If it looks really good, it should look like that. It should curl up at the top and at the bottom. Hey, usually I didn't draw that. but do it nicely here. Having organized math work is invaluable once you get to some crazy stuff in college. In practice. So this tells you to take the integral. You also need to write this dx, and I'll tell you about what it means in a second. All right, come on. Let's stay focused here. We're doing an excellent job so far. All right, so let's just label a couple of these things. Okay, that's called an integral symbol. It tells you to take the integral of something, which basically means take the antiderivative, right? Like we said before, but we're also going to add that plus c. A lot of terminology today. I apologize for this in advance. I should have given you a vocabulary template. This f of x, anybody know what it's called? No. All right, so the inside of an integral. All right, let's see if you guys remember anything from your primary schooling. If you add a times b equals c, this is called the what? The product. Beautiful. And what are each of these other things called? No. Good idea. No. That's funny. Reagents. No. These are called the multiplicands. Is that right? Or did I make that up? All right, forget it. Maybe that's not true. No, multiples is multiples of 3 and stuff like that. I'm pretty sure they're called multiplicands. This is called the integrand. It's the thing that's being integrated. I think that's in, what do you call it in division? It's a quotient, right? What do you call the thing on the top? No, that's the thing on the bottom, the thing that you're dividing by. Is it dividend?
Yeah.
Right? And so I think it's you adding that and or in is the thing that you're doing it to. That's what it means. But I'm not really sure. Like I said, I'm very official with my terminology. But this is actually definitely called the integrand. Yes?
So is it just the f of x that's the integrand?
Yeah. This is going to be whatever's inside here you call the integrand. And this dx thing, well, I'm going to wave my hands, and a miracle's going to happen, and we're going to worry about the dx later. Okay, basically what it tells you is you got to do the implicit differentiation, right? So you know how you can take the derivative with respect to y or the derivative with respect to x. This is just telling you that you're integrating with respect to x. Can you believe me on that for now? We'll worry about it later what it means exactly. Yeah.
I thought that is the integrand, which is what it means.
Anti-differentiated. Yeah. It's the thing you're going to take the antiderivative of. Okay? I'll show you what it is in a second. Okay. So this equals f of x, big F of x plus c. Okay. We just said before. I know, right? No space.
Do you need paper? Yeah.
You're out of paper in your notebook?
Yeah.
Okay. So label all this junk. Label all this junk. All right, come on. We got to go, actually. I'm a little nervous about time. Well, no, I'm not. Okay. So, whole new bunch of stuff. A lot of stuff's getting thrown at you once. We've got arrows all over the screen, a bunch of text, we know what's happening. Big takeaways. This thing is called the integral symbol, and it tells us to take the antiderivative of something. Okay. If you take the indefinite integral, don't worry about indefinite for now, but you take the integral of this, you're going to get its antiderivative plus this big C thing, this mystery constant that helps us to specify that there are a bajillion of different antiderivatives, all contained within that C different constants added on to the integrated. All right. How do we feel? Raise your hand if you feel like you're in a tropical beach somewhere. All right, sick. Let's go. So basically, this is a whole bunch of complicated stuff to do the same things we were doing a second ago, right? You take the reverse power rule, you integrate something, and the only thing that's different between that and the one before is you slap a plus C on the end, right? Okay, so try it. Write these down with write down the problem, not just the answer, right? Huh? Plus C. The answer includes the plus C. All right, so here we go. The first one, you add 1 to the 4, you get 5. You divide by that 5, so 9/5 x to the 5th plus C. Raise your hand if you got that right. Raise your hand if you got the plus C. You didn't get it right.
If you forgot it?
In Mr. Fox's calculus class, okay? Mr. Fox had to start to get half the thing. It was my calculus teacher in high school. In Mr. Fox's calculus class, if you didn't have the plus C, you got 0 points for the problem. I don't know how Ms. Sparks is going to do it. It's really easy to forget the plus C, and if you forget the plus C, if I was as hardcore as Mr. Fox was, which I would never want to be, I would take away all the points. But on the test, right, on the AP test, they'll take away 1 out of your 9 points on a free response problem just for that C. And the average that you get on a free response problem, or that people get, is like 4 or 5 points, right? So that's like 20% of the problem right there. It's just remembering to write plus C. So remember to write plus C. Okay, right here in the top right, who's got me? Maishka hit me.
2x cubed.
Right, yeah, we take the 2, we add 1 to it. That gives us 3. 6 divided by 3 is 2. 2x cubed plus C. Got it? McCormick, hit it.
X to the 6 plus C.
You took the easy one, man. That's too easy. Okay, and the last one, everybody. Ready? 1, 2, 3. No, I set this up on purpose because I wanted you guys to correct me, and I just did it. Took extra time to do that. Okay, raise your hand if you forgot no plus C's. Raise your hand if you forgot 1 plus C. Raise your hand if you forgot 2. What?
We thought you said God plus C beginning.
Oh, so I don't
You
understand.
did get it.
You got all of them?
Third, yeah.
Okay, you missed one. It happens. Okay, great. Good work, guys. All right, last one. Let's do this one together. I'm forcing it right now, right? This is the very last little thing we're going to do, and then I'll give you the homework. The integral, it's on the board. The integral of root x dx. Write this down. All right, who's my radical master? Radical. Somebody I haven't really heard from a lot. All right, Morena. How should I rewrite this if I want to put it in exponential form?
X, D, I lied.
Well, forget about all the junky symbols and stuff. What's root x in exponential form?
Oh, X.
Right, so we want to rewrite it as x to the 1/2. Okay, and similarly, right, what's the derivative of root x? Go.
What?
What's the derivative of root x? 1 over 2 root x. Did you guys just memorize that? You should. The derivative of root x is 1 over 2 root x. Okay, so we're going to learn what the integral of root x is right now. Okay, but we go through the same approach, which is that if we don't have it memorized, we rewrite it in exponential form, as it is here. Everybody comfortable with that? It's the best if you just have your mitzvah. Okay, and now we're going to go through the same process. Remember, the process is, for starters, we add 1 to the exponent and then divide by the new exponent. Gotcha?
Yeah.
All right, let's add 1 to the exponent. What's that? 3/3 is 1. 1 and 1/2, which is 3/2. Okay. And now this is where it gets tricky. We need to divide by 3/2. Okay. Dividing by a fraction is the same as multiplying by its reciprocal. So what do I put out front? 2/3. Done, right? Thank you. Don't forget to slap the C on there in the end. No good right there?
You have to.
Why do you have to do your reciprocal?
Right, so it's the same thing we did before, right? We're taking the 1/2, we're adding 1 to that, we get 3/2. You good on that? Okay, and then we have to divide by 3/2. Okay, so dividing by 3/2 is the same as multiplying by 2/3. It's like an easier way of doing it, right? You can say 1. Where's my marker? So we have the integral of x, just a second, 1/2 dx. Okay, and we're saying that's x to the 3/2. We could say, and we could divide this by 3/2. Okay, but do you know what 1 divided by 3/2 is? It's just 2/3. Okay, so just multiplying by the reciprocal is easier. I don't know why you're laughing. All right, any other questions?
Oh.
Why does it say x? That's not right. Don't look at that. What does Miss Sparks usually say?
You change it back.
Change it back.
Hey, what?
I'm just asking whether you needed to change it back to radical form afterwards, which I just did because it was not correctly written. It's good practice, guys, because on the test, right, they could give it to you either way. You should know how to quickly convert from one to the other. All right, you think you got this?
Yes.
Okay. All right. So go ahead, do this one on your own, and then we'll regroup on that, and then I'll give you the homework. In fact, I'll pass it out right now.
What? Negative 1 plus 3 is 2.
What's negative 1/3 plus 3 thirds?
I'm beasting on this whole
All right, let's do this. So, how do we rewrite it? MJB, x to the what?
X to the negative 1/3.
Right, okay, because it's in the denominator and it's a cube root. Okay, cube root. All right, so now we're going to take the indefinite integral of this, which means we add 1 to the negative 1/3, which everyone is what? Fraction masters? 2/3. And then we have to multiply by the reciprocal, which is 3/2 x to the 2/3. And we're not done because we need a plus c. And then if you wanted to rewrite that, it would look like that, right? The 2 becomes the exponent, and the 3 becomes the cube root. How do we feel about all this junk? Okay? All right, hit that homework. Let's go. If you can't read anything on there, let me know. So, guys, on the homework, listen. H on the 2 side, so the back side, part H, it's the bottom right on the back side. I did a terrible job of writing that. It says negative 2/4, okay, which is a silly thing for it to be in the first place, but that's fine. Negative 2/4, okay. Can you see that too? It's really bad. Thanks, Mariska. I need that support sometimes.
Wait, what?
Number 2, the backside, part H, it says x to the negative 2/4. I just can't write. You know that already. Okay. Go nuts. When you're finished,